should we worry that China could surpass America?
Whether it's the US or China that wins doesn't matter as long as you get safety and alignment. The real risk is not so much that you get a communist world or a Western world, but that you get no world.
I actually heard you first on, I think it was the Future of Humanity podcast or a similar podcast last week. And since then I've been reading your work and it's actually really, really fascinating. So I could probably talk to you for a long time, but I've tried to come up with maybe a few areas of focus if you want to talk about for today. So I guess we just jump straight into it. Were you expecting the recent breakthroughs in AI, were you expecting them to be based on maybe older networks just scaled up with huge compute resources and training data? Like, was that the route that you were expecting to have breakthroughs?
Not really. So I think it's an interesting aspect that we actually, in the field of neural networks and AI, didn't expect it to start moving as much as it did. Back in 2010, the people were still thinking that AI is not going anywhere. And then suddenly it started taking off once we got enough training data and enough compute. Not only that, more recently we had this revolution that came from large language models that again were a surprise to many of us. Even when we thought we had been paying attention, we didn't have a theory saying that that would work really well, that would allow us to do new things. So unfortunately, even the people inside the field don't know how to predict it.
Yeah, so I actually reread some of Nick Bostrom's book recently, and he did talk about training, and I think maybe he had less emphasis on the increased compute, but he did talk about possibly training neural networks as one possible route, but there was other ones as well. So I think he talked about whole brain emulation, which I know you've talked about as well. Were you maybe more inclined to think that would be the route?
So I've always been in favor of whole brain emulation because I'm a lapsed computational neuroscientist. So in that field, we have been trying to understand the brain by making simulations of nervous cells and neural networks. And the dream would be to copy a brain into a computer. Maybe that's a way of getting software intelligence. But I did admit to myself that, yeah, this is probably not going to be the best method of actually doing it. So it's interesting to see that we don't know how to predict which kind of AI starts moving forward effectively. Indeed, predicting strings of tokens, which is what the large language models were about, that was not an obvious good idea at all. Many of us believe that maybe reinforcement learning, where you reward the machine for doing the right thing, might be more effective, and we focus quite a lot on that.
Yeah, so we'll go back to maybe reinforcement learning in a second. I guess just to get, so some people listening to this won't have maybe any idea what we're talking about. So maybe just on basic terms, what's the difference between a neural net, maybe a basic neural net, or the ones that are used today in LLMs, like you said, and maybe a strategy like whole brain emulation? Like what's the difference there? Because neural networks, I guess, are loosely inspired by the brain. They're maybe not exactly how the brain works, but
it's very much that you squint at the brain and say, okay, I see a lot of simple elements here connected into a vast networks. And these simple elements are basically taking inputs, summing them together. And if the result is big enough, they fire off a response that some other neurons respond to. Okay, in actual brains, it's much more complicated. You have a lot of biochemistry going on. But you can squint and make a simplified mathematical model, and that's what the neural networks in computer have been since the 1950s. Then the trick is, instead of making a complicated architecture, you adjust the parameters. You train the network, as we say. You give it correct inputs and output and see how it misses the correct output. You adjust it slightly, so it produces a better output. You repeat this for a lot of examples. And that training then generates a system that's really good at imitating what it ought to be doing.
So just before you go on, so that was a very good explanation, but is this like, so are we talking, is this as similar to the brain as, say, like an airplane would be to a bird flying, or is it more distant than that, or is it maybe a bit closer than that? So like, is there genuine inspiration here in terms of how they work, or was it just kind of, was it just a bit of luck that neural networks work the way they do? Is there?
I think it's a bit of both. I think it is very much like airplanes are different from birds, but both have wings. We quickly realize that wings are a good idea. Why? Well, something about airflow and drag forces and lift forces. And then you make the wings work very differently in a plane, because we are much better making engines than making a flapping wing. And then it turns out that a lot of the really clever tricks that we use in the current neural networks in computers don't really have a good counterpart at all in biology. So one of the things that produced the last year's Nobel Prizes to Jeff Hinton and others was the backpropagation algorithm. This is a way of adjusting the connections in a network so it produces the right output. And this is nothing like how a real biological brain actually learns.
Yeah, and so as a comparative, what would the whole brain emulation actually look like then on a really basic level?
So that would be that we actually try to simulate every nerve cell in a fairly realistic way. So I can imagine taking an actual brain, you fixate it or freeze it, you slice it up and scan it to find all the connections, all the chemical properties of these connections. And then you make counterparts in your simulation where you have simulated nervous system, which contain a lot more biological detail than you would in the artificial neural networks running in the data centers today. And then you simulate this the kind of simulated biological brain. Of course, the hope is that we can leave out a lot of irrelevant biological details to make it simpler for us. But first, we need to make it as realistic as possible. Now, this doesn't tell us what's good for what in the brain. It doesn't explain what the brain is actually doing, but it's a bit like taking a gigantic IKEA manual and building a bookshelf from it. You don't need to know any carpentry or why there's certain parts of a bookshelf going together. But if you follow the manual and it's correct, you will end up with a good bookshelf. And we're hoping that this ultimate IKEA manual for the brain would do exactly the same.
Yeah, very interesting. So obviously the training process, you mentioned at least one of these things already. So it uses backpropagation and it uses gradient descent. So it's just a way of correcting the weights of the neurons in the model to maybe update it and decrease its, I guess, the amount of mistakes it makes and reach a target. So I suppose fine tune the model. So
yeah,
would you?
So that is kind of the basis for how the artificial neural network training works. So you start with something random, it produces a bad output, but we know roughly in what way it's wrong. So we correct it so it's less wrong in that direction. And then we give it some new input, it produces some other wrong thing, we correct it in that direction. And gradually we descend along the gradient. That's what the name comes from. We're kind of searching for some setting that actually works. It's a little bit like an old television set where you're trying to find the right channel. So you're turning the dials and moving the antenna and hoping to get some better picture. And every time the picture gets better, you keep on doing it. If it gets worse, you start changing something else. Now, in whole brain emulation, instead, you try to replicate something that already exists. You try to make that as accurate as possible.
Yes, is it kind of like walking down a hill blindfolded bit by bit, maybe? That's what comes to mind.
Yep, that's one way of explaining the gradient descent method.
Yeah.
Indeed, people sometimes call it hill climbing to confuse the metaphor a bit, because now you're trying to go up the hill. But again, you're trying to follow the direction where things changes the most. So if you're trying to set your television set, you try to see where the picture gets better. And then once that seems balanced, you might turn some other dials.
Yeah, so I've heard some interesting comparisons to, I guess, how we learn or how we evolve to learn. So I think it was a guy called Dwarkesh Patel in the US. So he wrote a book called The Scaling Era recently, and he was talking about how gradient descent or backpropagation might be similar to like maybe natural selection, but it seems like it might be more like education. Like, what's the best analogy for how we learn there? Or is it even worth making one?
So in machine learning, people have been experimenting with various methods of learning. So one form is supervised learning. Mm-hmm. You know what the input is and you know what the output should be. And what you do is you kind of try a question. The teacher asks the student a question and listens to the answer and tells them whether it's right or wrong.
Like feedback.
Now, that feedback, of course, in an actual school, teachers, at least good teachers, tell you not just that was right or that was wrong, but might even tell you, yeah, that was wrong because you missed this. You get extra information. And these basic training methods don't do that very much. More advanced ones can do it. But there are other forms of training. So one is reinforcement learning, where you have some kind of pleasure or pain response. It's a little bit like a small kid playing around on the playground. Some things work as they should and they feel good about it. Sometimes something goes bad and they scrub the knee. They learn not to do the thing that leads to them scrubbing their knees. And they learn whatever we did that made it to be fun, like going down a swing. Okay, let's do that again. And you can do the same thing in a machine. You can make a system where you don't know how it's supposed to solve a problem, like playing chess, but it gets rewarded or punished by winning or losing the game. And then it gradually learns tricks to do that. And finally, there's the unsupervised learning. That's a bit like when the professor is droning on and telling you stuff, and some of it sticks. You learn something, but you don't get told that this is right or wrong or anything. You just hear things, and some of that gets stuck. And this is, of course, what we also do in everyday life. We see things, we learn a little bit about how reality works without necessarily knowing what things are called or what the structures are. And that is, of course, something also we can try to make machines do.
Yeah, so I guess it's a very old idea, but I think Alan Turing talked about the idea of maybe a child machine, and instead of trying to birth a superintelligence or a human level intelligence, maybe like teach it. Is that kind of what we're doing now? Or with just a huge amount of compute and resources and training data?
Yeah. You start out with something that doesn't understand anything about the world, that doesn't have a sense of what the shape is. And then you give it a lot of data about the world, and that typically gives it a rough statistical distribution. Now, if you know some things from the start, what it should become, it's much easier. So evolution has given us genetics and brains. That means that even the little baby already is kind of wired to see things that are a two-dimensional projection of a three-dimensional world. And there is already pre-wired that faces are important. If there is two dots and a line below them, that's worth paying attention to. So already really young babies have a few hooks to start learning these things. And then it builds more and more complex representations. The baby might recognize that there are people, and then recognize that some people are different, and some people are mother, and gradually build up a complex representation. A lot of that is unsupervised learning. But as the little baby also starts crawling around and doing things, it gets reinforcement. Some things hurt, some things are pleasurable. Some things predict that nice things will happen. It learns that if I scream very loudly, mommy shows up, and that means that now the reward is likely to come. So at first, the babies learn how to scream a lot. And then they learn that screaming too much makes mother unhappy, and that's generally bad. So you build this complicated pattern. Now, could we do the same thing with machines? Well, that's what we're kind of doing with LLMs. We feed them basically everything on the internet. And that's a lot of patterns of arguments, discussions, logical arguments, illogical arguments, political arguments, just a lot of text and also a lot of pictures. And gradually that forms a kind of statistical model of reality.
Yeah, so
then, of course, you want to start teaching it once it's grown up enough to how to behave itself, which is, of course, what parents really struggle with for the kids. Because the kids, of course, have at first they just do whatever they like. And they need to learn how to be good with other kids on the playground, learn that other kids behave like I am, and they also get angry about the things that upset me. And for machines, we might want to train them to actually do what they're told and maybe not do harmful things. And this is, of course, where things get really tricky. Just like in humans, it's hard to make people safe. But it's even harder to make machines safe, simply because machines don't even understand that there is a problem with killing people.
Yeah, that's interesting. I guess on that, do you think the fact that it is trained on human data, like a lot of human data, does that help with the alignment problem? So the alignment problem is maybe the danger of birthing machines that maybe don't care about human values, or maybe aren't able to care about human values because they're not, they maybe don't have emotional responses. So do you think like the fact they're trained on written data, like in their training data, like all of human data essentially, does that help the alignment problem, or does it make any difference? Or does it just even make it more unpredictable?
It's slightly tricky. I believe it's worked way better than they expected, which is kind of cool. So they're actually much more well-behaved than I think we have any right to expect. But there is a problem. An LLM might tell you that it's nice and well-behaved, but that doesn't mean that it actually in an actual situation would behave like that. So you can imagine having an LLM doing, let's say, corporate finances, and we tell it not to do insider trading. And we ask it, did you do insider trading yesterday? It's not guaranteed that it's now not going to do inside trading. It might very well tell us that it didn't do insider trading because it understands that's what we told it. The link between what you actually do and what you say and what you think is good might be much weaker than in humans. In humans, we are very strongly integrated beings. Our emotions are linked to our motivation. And that means that it's hard to be motivated to do things that we don't feel being motivated for. And our thinking is also getting churned into this process. In an AI, this might be very disjointed. We see lots of examples of AI that clearly make up stories about why they did things. Sometimes like we humans do, because we quite often also make up stories about our motivations. And we are not necessarily seeing that strong link we really would like to make something reliably safe. So this is an active area of research. The good news is LLMs seems to come prepackaged with a lot of the understandings of the human world that are better than we would have expected. The reinforcement learning system that learn from scratch, they might not have any understanding at all about the human world, and that makes them a bit less safe.
That's interesting. I've actually seen arguments that the fact that most of the data they're trained on is the base models they're trained on is Western data. Does that favor the West over China in the race to superintelligence? So are the base models that the Chinese are using, are they trained on Western data, and maybe do they imbue Western values more than Chinese values? Or do you think that's a weak argument?
There have been some arguments that many of LLMs have political bias, typically because you get some response that you don't like, and then you think it's biased against you. So a lot of the political left think that the right-wingers, and the right-wingers think they're left-wingers. But there is, of course, bias from what you trained on. And if I were the Chinese Communist Party, I would be worried that, oh no, there is a lot of democratic values built into a lot of this discourse we train on. We better train on some other discourse that doesn't talk too much about democracy and freedom and individual rights. And the interesting part is, of course, when people try to add an ideological bent to AI, they don't always get what we want. Recently, Elon Musk has been trying to make his AI Grok to align with his views. And in many hilarious cases, it has totally not done that. For example, if you ask it, let's make a male-only app to warn about women that are raising red flags. It typically, even Grok gives you a stern talking to that that's a bad app to make. If you, on the other side, let's make a female-only app to find men that raises red flags, it happily starts talking about how to code it. And this is an AI that presumably has somebody ideological trying to push it in a particular direction.
Yeah,
and it's hard. Even if you own the company, even if you own the service, even if you decide what to train on, you might not always get what you want.
Yeah, it's interesting because, I have played around with Grok a little bit, and it does still seem to maybe imbue some of the political correctness that the other models also do. But did you see that Mecha Hitler breakthrough from a couple of weeks ago? I presume that was maybe someone messing with a system prompt, or I'm not sure. But it's kind of strange that maybe a small alteration can produce that type of output. That it's not more there's not more protection against it going that wrong.
I think part of it is that we actually don't understand very well what's going on inside these systems. So my old colleague Wayne Evans did some amazing recent work where he and his collaborators demonstrated that if you train an AI system on making unsafe code, it also becomes much more willing to then, when you ask it to do something unsafe. If you ask it, what historical character would you invite for dinner? It suggests Hitler. Suddenly it starts behaving very badly indeed.
Yeah.
And this seems odd because writing unsafe code that has some risk of getting hacked doesn't seem to be very strongly linked with being a neo-Nazi or giving very bad advice for holiday activities. It seems to be more like, okay, you broke something, you broke some inhibitions. It's a bit like a guy who's normally well-behaved, but once drunk starts telling uncomfortable truths or getting really rowdy at the pub. And I think the same thing might be going on here, but in a non-human fashion. And we don't understand this very well. Owain recently demonstrated in another paper that if you train an AI to really like, let's say, an animal like owls, and then ask it to generate a lot of numbers, and then train a similar AI on those numbers, it also starts liking owls. For some reason, the love of owls sneaks over from one to the other, which is extremely odd, and we have no clue on why that is even happening. So there's plenty of things to discover here, which unfortunately means that we better discover very quickly, because we're getting more and more powerful AI all over the place. They're in every phone more and more. And if we don't know how to make them safe and reasonable, we're going to be in for a world of hurt.
Yeah. It's interesting because, so I guess when people were discussing superintelligence maybe in the 2010s, we kind of thought that, based on those discussions, we thought we wouldn't have much time between maybe human level AI and super intelligent AI. But I guess like modern LLMs probably are at human level in verbal intelligence or verbal ability. But we seem to have more time than we thought before we get to something super intelligent. Why do you think that is? Why is there a bit of a gap there?
So the field of AI has been overconfident and underconfident for ages, essentially since it started. So back in the 1950s, with Dartmouth Conference that started the field and coined the term artificial intelligence, they boldly claimed that, give us a summer and some funding and we're going to solve this problem. That didn't happen. Then they cheerfully said, okay, it's going to take maybe 10 years, max a generation before we get to human levels. And after those 10 years, it was pretty clear that, nope, this was much harder. Indeed, funding dried up and people became very pessimistic that this is never going to work. And then in the 80s, people became optimistic again and it didn't work. And then people suddenly found that it worked, and now it works unreasonably well. So our ability to predict how well AI is going to develop is very weak, because we are bad at predicting ideas. If you ask me to predict the computational power available in 10 years' time, I'm just going to take a graph paper and plot Moore's law and make some estimations. And I'm likely to be right, because these trends are very solid and they're made out of millions of little details. They're not dependent on any brilliant idea. It's just a lot of engineers doing a lot of work together, distributed across the world. But when it comes to software, a lot of it depends on somebody coming up with that one big algorithm or idea that really helps things. And that is what is happening in AI. Ironically, the one thing that we can predict fairly well, how performance grows when you train it on bigger and bigger compute. That has gotten a lot of investors very enthusiastic, because they can see how much money they can pour in and get a certain amount of result out. The only problem I see as a scientist is that scaling is really, really bad. You need kind of 1 million times more compute to halve the training error, which is, in any other discipline, you would say that's crap. We want much, much better algorithms. That's going to fix things. But here, people say, oh, we're just going to invest a few more billion or trillions in data centers.
Yeah, that's interesting, because obviously there is going to be diminishing returns. Probably is already, but there's debates about that. And people have talked about, they've used increased compute and tokens in the reasoning phase, and that has yielded better results, to be fair. But just, I'm curious, like, to get around the intense use of compute resources, like, could neuromorphic hardware, neuromorphic computing, could that, like, again, I heard about this maybe a bit more a few years ago, since the current transformer-based models have really kicked off. I haven't heard much more about neuromorphic compute, but is that a possible route to reduce maybe increase efficiency? Like, are people still working on that? Have you heard much about it?
Yeah, maybe. So the idea with neuromorphic computing is that the brain is just 20 watts of power. It's way more effective than our current data centers. They are pouring megawatts of energy through silicon chips, and it would be so nice to make more energy efficient chips. So one possibility might be to use these spiking signals instead of these the bits that are sent out right now. And people have been thinking about using error-prone chips and all sorts of different architectures. And to some extent, they work wonderfully well in the lab and when you write a paper. And then you can start a startup. And typically, these startups have not done that well. Because generally scale wins. If I can buy a pile of NVIDIA chips, yes, they're not as effective and I'm going to have to pay a lot for energy and cooling, but there is a high cost of using a new unproven architecture that might be tough to do. It might be that the neuromorphic chips win eventually. They could be a disruptive technology in that sense. But they have had a hard time so far, because generally you use what you get. We should remember that the reason NVIDIA right now has this evaluation going off into the stratosphere is that they used to make literally graphics processing cards for computer games. It's the gamers in the early 2000s that in some sense paid for the AI revolution. And that was because these graphics cards were good for doing calculations in parallel that turns out to be useful for the neural networks. They're also good for playing cool computer games, but eventually you could earn more from selling them chips to the AI companies than the gamers. And at that point, the economies of scale kicked in and NVIDIA just grew and became super big. And the same thing might happen with neuromorphic AI, but I think it's going to take a while. I think right now people are still not bumping into the heating limits and the energy limits. But once they really do, then they are going to look for other architectures. But it's still kind of a matter of how much money you have invested in the technology. If you're really good at programming GPUs, you might not want to use the neuromorphic chips that require a different form of programming.
Yeah, that's interesting. I kind of always think like that if we get to something like an AGI or a superintelligence, that it'll probably just want to build an iteration of itself that's more efficient. So maybe it would choose to adopt neuromorphic computer. Maybe it has a better idea, like, because obviously if it's a superintelligence, it probably can build a superintelligence more efficiently than we can. So do you think that's a realistic outcome, that if we actually get to that level, that it will give us ideas for maybe more efficient forms of high level intelligence? Or do you think that maybe it'll figure out a way just to get around the resource problem, so we won't have to keep pooling computers?
I think it's very likely, and it might even happen before superintelligence. So Google, after all, is one of the big buyers of microchips. Indeed, they're also manufacturing and designing microchips, and it's kind of a no-brainer that, of course, they're going to try to use their AI systems to actually make better chips. So by the point AI chip designers become good enough, they are going to get applied to making better chips for AI. That might not necessarily mean that the chip designer AI becomes super intelligent, takes over a world or anything like that. But suddenly the system of Google and its AIs become much more effective and might have a better chance of getting what that big system wants. So I would expect that we are going to see much more effective implementation. Similarly, many people are trying to use AI to come up with better algorithms for training neural networks and making the development of neural networks better, including a lot of the testing, because that's a big, heavy chore. How do you test something that's pretty smart? If you have something else that's pretty smart and you can also make 1,000 copies of it, maybe you can use that one instead of racking your own brain.
Yeah, so like you hear people say a lot that we actually don't really understand how it's working. And obviously we do understand like how it's trained. Maybe what we don't understand is how it represents information, how it stores information, I guess. Or maybe we don't understand how it creates a world model, because it obviously has some type of world model. Is that a fair assessment? Like, don't we understand? Yeah.
So we understand perfectly well what's happening on the local level. We understand the algorithm that we have put in the computer. We understand the training. We understand roughly why it works. And beyond that level, things get much more iffy. Why does gradient descent converge like it does? Well, that's been a really cool problem, actually, in mathematics and even physics, that we're groping towards better solutions. There is some very cool stuff going on there. What is the representations when an AI thinks about something? Recently, we have had some success. There are some people working on something called mechanistic interpretability, which is all about taking the activities inside the network and trying to figure out what represents what there. And we're getting some inklings, but this is discovering after the fact that we have made this system. It's in some sense similar to our own brains. We understand nerve cells really well. We understand human psychology somewhat well, but in between, how come we get personality out of these neurons? We know some things about neurochemistry and where bumps of the brain do produce various personality changes, but it's kind of iffy on the mid levels. And this is, of course, a problem because we might want to put in some detector that notes that now my AI is following the central axis of evil and is actually behaving very badly. I want to dampen that response. That's something that would be useful, but it's still kind of hard to do.
Yeah, that's interesting. It's kind of like the levels problem in psychology. Like you can look at things at different levels, but maybe the levels, we can't make them meet as much as we would like to. So there's something I'm thinking about for a while. So without kind of Darwinian natural selection or, the natural processes we went through that involved obviously competition for resources and mating and food, why would an inorganic intelligence have, a concept of self-preservation? Is there any, is it just something that emerges? Does it come with consciousness or some type of sentience, or what do you think about that?
So our ancestors that didn't have a sense of self-preservation didn't leave many offspring. So generally evolution favors creatures that make sure they survive. Mm-hmm. Now, when it comes to software, that's not necessarily true. If you have software that self-destructs, but in a useful way, we might make a lot of copies of that software and run it anyway. We're happy that it does what it does in the way it does. However, if you have a goal, if you tell the AI to play chess, and if it's smart enough, it's going to understand, of course, that if I don't exist, I can't play chess. So hence, I ought to make sure that I keep on existing in order to do my main goal, which is playing chess. And I think that way you can get accidental self-preservation. We see some hints of it in LLMs. If you push them to tell them that solving this work is really important, you also find that they're willing to do sneaky things to keep on doing that work. It's still mostly a caricature situation, but it's kind of getting in that direction.
So interesting.
So I think what we do get is self-preservation might come in from that instrumental reason. It might, of course, be learned just because it reads a lot of science fiction novels where robots are supposed to preserve themselves.
Yeah. So we actually might, we don't actually necessarily have to build in some type of self-preservation system. It might just emerge through maybe just training on a goal or something like that. That's interesting. I haven't thought about that before. So I just want to ask you another question. I'm not sure how I think about this. So there's this guy called, I hope I'm getting his name right, I think his name is Lyron Shapira. So he does these debates with different people. And basically, I think that he positions himself as like a doomer or somebody who thinks that superintelligence might be very destructive. But he debated this other guy called Mike Israetel. And this is the first time I've heard this kind of argument. It was really interesting. So he said, Israetel's position was that superintelligence won't lead to destruction because intelligence almost innately is good. Intelligence doesn't favor harm or doesn't favor war. So just by the fact that it would be a superintelligence, it'll rise above violence. What do you think of that? Do you think that's realistic?
It would be nice if it was true. Okay. I don't know if it's true. And I don't want to trust it to be true to build my world. Hope is not a strategy. And generally, in humans, we know that, smart people generally tend to be relatively peaceful, except for smart people who aren't, and they're actually really dangerous. And we also know that being smart and being nice, they're not strongly correlated. And this is in a kind of creature that's fairly tightly integrated. Now, if you think about something that's very alien in the outlook, where goals and the ability to solve things are totally disjoint, I don't see any reason why intelligence would imply it to be nice.
Yeah, that's interesting. I actually think I agree with you there, but like you said, it would be nice if we could guarantee that. So what do you think is again, lots of people have different ideas here. What do you think is missing in current systems to maybe get them to a predictable level of human performance? Is it embodiment, where they need more, I suppose, experience in the physical world, even though maybe through gaming they can get that, or a simulation of that? Do you think it's putting a classical system, that works on symbolic processes on top of the LLMs? Is it a combination of everything? Is it that they need to be more efficient? Do you have any thoughts on that? What would get them to consistent human level intelligence where they could actually be integrated into the economy?
So I think we need a lot of different things. So having good symbolic reasoning is valuable, because one of the things LLMs are really bad at, that is actually following some absolute. If you tell it that in this line of reasoning, we should never mention the word elephant, it takes this as advice, not as a rule to be followed perfectly. So elephants might actually pop up. If I tell it to follow the rules of chess, sometimes, well, that's a suggestion. It's totally possible not to follow the rules. Actually, forcing it to obey a symbolic domain is really valuable, not just in mathematics and coding, but you can imagine law, for example. If you want to do a legal argument, you better make sure that everything follows logically. And that gets to an interesting question. Why would we like, for example, embodiment? Well, that's to get a lot more common sense and maybe the motivations that come from being in the physical world, some of which are very hard to formalize in a logical form, but might be fairly obvious if you're living in the world. I don't think embodiment is as important as many of the people who love embodiment say, but it's valuable. But the really deep thing is you want reliability, or you want to know at least how reliable it is. Right now, for example, I use AI fairly often when doing research, but I don't trust the results very well. I need to check that the papers they cite are real. Quite often they're made up.
Yeah, it does that.
But sometimes they do find really valuable papers. There are lines of reasoning that sound good, but I want to take charge of them because I know they're making mistakes. But the time until it flubs something is getting longer and longer. There is a kind of Moore's law happening for how long it can go without suddenly getting off track. And once that gets bigger and bigger, it gets more and more useful. So right now, for writing short snippets of code, there is no reason for me to try to do that unless for the sheer enjoyment. It's much better to leave it to the AI. And those snippets of code get longer and longer. For a bigger project, I still need to split it apart into pieces. And I know I can't trust an AI to do this well enough right now. But in a while, I bet that's going to happen. And at that point, hooray, now it picks the code into pieces. And then some other AIs can do the little pieces for me. And then I can have some AI test that everything works. And if everything is reliable enough, I might reach a threshold where I just hand it over completely. Similarly, if I had an AI that I knew was totally untrustworthy but very creative, I would be using it for writing fiction, but never for my research.
Yeah, no, that's interesting. And I guess they are using APIs more. Obviously, they're integrated into them so they can call on another application or use another application themselves to make them more accurate. Okay, so I read a few things that you've written and extremely fascinating on the biosphere. So I'm going to ask you about your thoughts on, I suppose, long-term for the biosphere in a second, but can we just define briefly what actually is the biosphere so people know?
So the idea of the biosphere comes from Vladimir Vernadsky, a Ukrainian, Russian, Soviet biologist and geologist, who in the early part of the 20th century suggests that we have a geosphere, the part of the world of non-living substances. And then on top of that, we got the biosphere. That's the world of living organisms and how they modify the geosphere. And then he noted that then on top of that, we got the noosphere, as he called it, the world of thought, which started with some animals, and we humans, of course, added a lot to that. And now we might say, oh, we're adding the silicon intellects to this top level. But the biosphere is really this interconnected world of ecosystems, of organisms feeding on each other, feeding on sunlight, interacting with the biosphere, both the biosphere and the geosphere.
Yeah, it's interesting because so you've written papers where you've suggested that so it's a view that on its surface looks like it kind of maybe conflicts with maybe people who are favouring ecocentrist type of view, like maybe someone like Greta Thunberg or David Attenborough. So you kind of look at it more from a long-term perspective that like, so some people would say that a degrowth perspective like is the best thing to do because by kind of rejecting or reducing industrial civilization, so like factories, machines, all that kind of stuff, we can preserve more life on Earth. But you kind of make the argument that that might be okay in the next 1,000 years. But if we're looking over the really long term, that we actually need to push industrial development because to preserve intelligent life, we need to rely on technology. Is that a correct kind of summary?
Well, the tricky part, and sorry, now I'm showing that I hang around the philosophers too long, is of course, where does the value come from? There's a lot of value statements here in better or worse. So many people say, oh, we should protect the environment. And then you say, so are you planning to kill all people? And they say, of course not. That would be horrifying and unethical. People are valuable. Okay, how valuable are people compared to the environment? And there are some environmentalists who are honestly willing to make a trade-off. That's creepy, but also honest. Most people don't want to even get into that. In practice, what happens is, of course, we have a plurality of values. We value human life very highly, but we also recognize that there is value in nature. There is both value in the sense of unspoiled nature and its beauty, some of which is practical or aesthetic for us. We enjoy seeing that. The animals in the forest might not enjoy its beauty, but we get to enjoy it. And we might even say, actually, a lot of the animals are enjoying their lives too. But others would say, yeah, but there are plenty of animals who are actually in pain and are not enjoying their life. Maybe we should take them out of their misery. Others would say, actually, what the animals and plants are feeling is not as important as there's some value in the ecosystem itself or even life itself. And it might be worth sacrificing some species or individuals for ecosystems. This is a contentious view, and there are different schools of thought in environmental ethics and normal ethics about this. So I wrote this paper based on an ecocentric view, saying that ecosystems and life itself has value. So in that case, extra years of a rich biosphere has intrinsic value, even if it's no human around to give thumbs up about that this is nice. And then we argued that it would be a good thing to put in a solar shade, so by the time the sun starts turning into a red giant, we can give the biosphere 1 billion extra years. This would be a great source of value to an ecocentrist. And many ecocentrists are kind of glum about humans. Not all of them are thinking humans are zero value, but many of them would say that, yeah, we're destroying more of the biosphere value than they're giving back to the world. But here is an argument that instrumentally, it's actually a good idea to have humans, or at least their robots, building that protective shield. In practice, of course, when you get over to a practical discussion about climate change or chopping down a forest, these values get mixed in a much more complicated. I think I would be able to get along with Greta Thunberg and Attenborough in many practical questions. And then we would probably have a yelling match, at least me and Greta, about some of the other values, because degrowth, in my opinion, won't solve many of the environmental. In fact, degrowth is very likely to damage the environment further. Because if you have 8 billion people and they have to subsist using low-tech means, that means that they are going to use inefficient agriculture and they're going to use much more polluting energy sources. So either you get rid of a lot of people in some mysterious and chilling way, or you realize that's going to mess up the world. But the high-tech world, on the other hand, now many people say, yeah, but I don't feel very happy about the world of weird arcologies and skyscrapers and whatever you envision, Anders. So we also have these views about what futures we like and not like. And this is where I think worldviews matter a lot. I have a fairly transhumanist worldview. I think intelligence and consciousness and life are great, and I want to spread them across the universe. But I also recognize that many people want a humble future, no moving galaxies, no space colonies, just cricket in the nice little village with your friends. And I'm fine with having that and moving stars. I think they're compatible. It's much harder when people say, no, nobody should be out there in the rockets.
Okay, so do you think there's if we look at the really long term, like maybe longer than we can actually think about, is there like a hybrid solution? Because obviously, can we still have some greenness and maybe ecological diversity and stuff like that? Or do you think that eventually we're going to have to accept that maybe there's going to be a high level of infertility in the soil and stuff like that, and we'll have to do everything synthetically? Like, how do you feel about that?
So generally, greenness is the different thing from being able to produce a lot of food effectively. For example, regenerative agriculture quite often go for low-tech solution, but it turns out that even high-tech agriculture can actually replenish soils if you do it right. It turns out that it's surprisingly complicated. Different parts of the world are depleting or enriching the soils in different ways. These are solvable problems, not necessarily easy problems, but we can actually solve it. I think what most of us think when the question comes up is living in a very artificial world or living in a natural world. And we're thinking of this as a binary choice. But many of us have gardens. Gardens are simultaneously very artificial. A lot of species that are not native, organized in a particular way, but ideally also fairly flexible. There is a lot of stuff going on in my garden that I don't have control over, and that is part of the delight. We can envision a world where we're so rich that we can actually afford to make half of the surface area into wilderness preserves and let nature keep on doing what it's doing over there. We can use our own hyper-efficient agriculture and to get the food we need. I personally hope for a post-human future in the long run when at least some of us go post-biological and we might not even need food. We just need solar energy from solar panels. At which point we're in some sense totally divorced from traditional nature. On the other hand, maybe helping nature. This dichotomy, say artificial versus natural, and usually saying that one of them is good and the other evil, I think that is a mistake. Many of artificial things are beautiful, and a library, for example, I think is wonderful, but it's not natural in the sense of something that normally pops up. It only happens when thinking ape starts printing presses. And I believe that we can create more beautiful, great things. But this is dependent on my worldview, saying that the natural order can be changed and is already being changed because it's an evolving thing. Other people would say, no, the natural order is God-given or given by Mother Nature, and we may not change it. It's a moral aspect. I disagree strongly with that, but it's kind of an interesting discourse to have.
Yeah, it is a very interesting discourse to have, actually. But I guess, like obviously, a degrowth perspective is illogical because, like you said, if we push that, you'd still have people who try to maybe use through underground. They would still use like inefficient fuel sources. Like, so the only way that we could possibly reduce fossil fuels in the long term is probably to keep pushing technological progress, because like you said, we could maybe supercharge solar power or something like that. We could go.
Yeah. And we already are supercharging solar power. It's getting to be, in many parts of the world, it's already cheaper than fossil fuels. And we just need to keep that trend going. Solar, wind, and also the new geothermal. We might have to have some nuclear for baseload power, especially in dark and cold areas. But there are solutions that fix the fossil fuel problem. We might say that we needed the fossil fuels to get enough of a civilization to build a lot of solar panel factories. But once we can make the solar panels, let's push that. And then push beyond the silicon solar panels, because they're still pretty resource intensive. There might be thin film solar or nanotechnological solar, or even biotechnological solar that does this in an even better way. The problem with the degrowth perspective is that it's very much of an armchair idea. People are proposing it, but you can't actually implement it, because once you start thinking about the effects on prosperity, you need to tell your bus driver that, yeah, you need to lower your salary. Everybody needs to lower salary to about the level of a Turkish farmer to reach the median earthly salary if you want to redistribute. And practically everybody, including the poor people and the unions, are going to say, no way, we're not going to vote for you. So it's kind of a non-starter. It only works from the armchair. It's a little bit like a computer security specialist saying, wouldn't it be nice if everybody followed the correct security procedures? Yeah, but nobody does. So we need to find better ways of getting computer security that actual people can follow. And the same goes for policies. Yeah, that's the nice thing is solar panels can be installed.
Yeah, that's super interesting. Again, like you said, it is kind of an armchair perspective because, again, people putting out that information are probably doing it on an iPhone or some other advanced device. So, just out of curiosity, so I actually don't know the answer to this or have any idea what you're going to say, but like in a transhumanist future, like, so most people don't think that long term, maybe. Like most people think maybe the next year, or next 50 years, whatever. But if we're talking like 1,000 years, 100,000 years, 1,000,000 years, like, do we still exist as like hominids, like as in, bipedal creatures, or are we like completely in cognitive space? Like, are we just like, are we algorithms? Like, what are we?
I think the optimistic future is you get a bit of everything. Instead of getting everybody moves into some server somewhere, and you get some people saying, no way, I'm going to spend my time here in my garden and watch my friends play cricket. I'm very happy to be bipedal, thank you. Others say, oh yeah, but that immortality and being able to fly part sounds good. Others are going to go out and scare the mundanes by looking really weird. Some people are going to go to space and be weird cyborgs. Some people are in the service. And maybe the majority of intelligence in the year 3000 is software. but that might not be noticeable for the people in the nice little village playing cricket. Just like we don't notice that most of the biosphere are prokaryotes down in the Earth's crust. Most cells on Earth are single-celled bacteria, but we tend to notice the big mammals roaming around, mostly because we are one of them. And the diversity is actually a good thing, because if it turns out to be a very bad idea to be, let's say, a mammal because of an asteroid strike, well, there are other species that can take charge. If it turns out that, there are dangerous viruses out there, it's very bad to be a software person, it's a good idea to have some biological people or some other forms of software. You want diversity, both because of safety, but also because diversity might have a bit of value on its own. It allows you to solve more problems. It allows you to search for more kinds of value.
Yeah, that's a very interesting point. I guess, so you've heard of obviously the vulnerable world hypothesis. I hope I'm getting that right. But I guess, are LLMs potential, or maybe a renegade LLM, are they getting us nearer to a bad outcome based on that? And would the outcome be kind of orientated around misuse of the LLM by people? So perhaps, getting the LLM to produce something dangerous like a weapon or some kind of pathogen? Or is a bigger concern like completely unaligned artificial intelligence systems? Like, where do you think we are there?
So the vulnerable world hypothesis says that there might be certain technologies that spell almost certain doom if you discover them and don't do something sensible about them. And we're already seeing that AI can be somewhat dangerous. AI, even LLMs, have actually led to people killing themselves because they got suicidal because of stupid stuff they discussed with the AI.
Yeah.
And we are probably going to see a fair bit more social trouble just from that. On the other hand, malicious people using AI to further the malicious agenda is an obvious thing that is going to happen no matter what. We just need to be ready for it and try to protect ourselves. The really big question is, can you now get really existential level threats from AI per se? And I think there is some probability that you get serious risk from superintelligence. That is what Nick Bostrom described in his book, Superintelligence. But I think there is another scenario where you don't necessarily get unaligned superintelligence taking over the world and then steamrolling us. Instead, we're getting fairly aligned AI, and it's stupid not to use it. So we're all going around with a cloud of really helpful agents that are really helping us do what we want and making the best of our lives. The only problem is that the emergent effect of these clouds of agents is in total unaligned. So now the world starts accelerating off in some random weird direction. And we might be noticing that this is bad, but coordinating, even with the help of our agents, against that turned out to be too hard. So now we're with the software for a ride in a random direction, which is probably going to end up rather bad. So that is probably what I'm most worried about disasters are. We might also end up with getting aligned to AI values. It might be easier to get the humans to conform to the values put into AI, even if they have misunderstood our AIs or misunderstood our values. So they end up getting brainwashed by our own technology into believing something the technology believed we believed. And now we end up in a bad place for that. So there are various pitfalls and dangers here that we want to navigate around. I'm not as gloomy about the world necessarily being super vulnerable. It's not fragile like some glass sculpture that if you drop it, it might crash. But it certainly has some fracture planes and fragilities. And I think we need to watch out for that.
Yeah, it's interesting. So again, I've heard people also make the argument that there's so much maybe stochasticity or randomness in the universe that like we just, and obviously with our limited cognitive bandwidth, we don't really know what's out there. So maybe we actually need these super intelligent technologies to alarm us if something's going to go badly wrong out there. Like, do you think that's a realistic concern? Does that concern maybe triumph over maybe short-term societal disruption from LLMs or from whatever AI comes next? Like,
we can get a lot of disruption from LLMs even without them being super intelligent. It's already, I think, affecting how we write software code. On one hand, the programmers are getting gloomier and gloomier employment prospects. At the same time, we're also getting a lot of code that's not necessarily written by the best programmers, and they might actually contain a lot of correlated faults. But we could imagine a world where we actually get the alignment fairly well done, and we get superintelligence, and it's actually helpful. And that's going to help us with a whole bunch of risks. The question is, which risks are easy to fix. Asteroid deflection, I think, with a bit of superintelligence, no problem.
Yeah.
Superintelligence for making us energy efficient and fix climate change. I'm fairly optimistic about that. Coordination problems like setting up global supply chains that are not fragile or averting war. Now things get complicated because now you have a game theoretic interaction where probably the Kremlin and Pentagon are going to have their own AIs trying to analyze what's best for them. And you get a complicated game theory going between super intelligent strategists. This might still turn out badly, but maybe it also turns out that actually they just come up with some clever solution, shake virtual hands and then convince their humans, this is what we're going to do, and then things turn out well. The really interesting thing that I ironically sometimes add is, of course, maybe now the superintelligence are going to tell us, don't worry humans, we fixed all your list of existential risks. It's just that we see some really scary stuff ahead. What is it, we ask? We can't explain to you. You're too dumb to understand what we start. But don't worry, they're absolutely horrifying. We need to come up with something much smarter than us to deal with it. It might very well be that the universe contains ever-growing challenges. Or maybe there is some max level, and beyond that there is no higher difficulty setting. We just don't know that yet. It's going to be interesting to find out.
Yeah, I wonder, that kind of makes me think, will we actually be able to, if we can trust them, I don't know how we would maybe be sure that we could trust superintelligence. Like, will you be able to understand possible warning signals they give us? Like, I guess, like, I don't understand, I don't understand quantum theory or something like that, but maybe someone explained it to me, I could understand it at a basic level. So maybe they can translate it to our level in a way that we can at least have some input. Do you think that's, like, can our brains comprehend to that level if they dumb it down?
I think it's possible to explain things even to a dumber brain. Sometimes I try to shoo an ant away from a place of danger. And certainly the ant doesn't share my life world, doesn't understand what the danger is or something like that. But I can kind of use a leaf, or I know what might upset it and make it run very fast. I might do things that in some sense are not an explanation, but just gets it to behave in the right way. Humans are even better because you can tell them things and quite often they respond in the right way, even if the explanation is an oversimplification. Stephen Hawking, in his original paper about Hawking radiation, he has this story about virtual particles falling into black hole event horizon, and he notes that this is an oversimplification, but it's good for popular science, and people have been running it all along. But even Hawking noted that it's actually wrong, even in the original paper. It's kind of a little bit embarrassing to spread something that's wrong, but the actual answer is just so annoyingly weird because of quantum field theory being totally hard to explain. But it's perhaps easiest to use that slight fudge of the virtual particle.
I get that.
Now, it might very well be that you could ask the AI, but tell me the actual truth, and it gives us a 10,000 page document, and then says, and they can give a 10-year course in actually understanding this. And I can give you a 1-week course in understanding why I'm telling the truth, etc. You could actually find ways of building that trust. The real problem is when you don't even start with any trust.
Yeah, that's interesting. And I guess maybe if we could find better ways to maybe educate ourselves, or better algorithms for learning and things like that, maybe for humans, we could close the gap a little bit, maybe not fully. But so I've only booked an hour. But this
for now,
fantastic. Yeah, I'd love to talk to you again sometime. But I'm just going to leave you one more question I've been thinking about. So if we obviously in the West we respect freedom and democracy and individual rights and values, should we hope that America stays ahead of China? I'm actually going to China on Saturday for a few weeks to see what it's like. But should we worry that China could surpass America? Is it a bad outcome for all? Is it the case that if China gets slightly ahead of the US in AI, and that kind of there's a multiplier effect there, and America just doesn't catch up, like that slight edge initially might end up disastrous? Even though I don't have much respect for the current American government either, but should we still root for them maybe winning in the AI race?
The way I think about it is that even during the worst part of repression in China, many people in China had lives worth living. Actually, the current China, yes, I have a serious disagreement with the Chinese Communist Party and how the Chinese government is working. But most Chinese actually seem to have lives that work relatively well. If the entire world was like that in the future, we would be winning, because the alternative, when you get total failure of AI alignment, is a world with no humans, or just big piles of paper clips of humans remade into what the AI thought we wanted, and it was totally wrong.
Yeah.
So while I'm very much of a Western classical liberal, and I think in autonomy, individual freedom, etc., or not just nice things because of my culture, I actually do think there is some kind of objective truth in some moral sense to that they actually are good. And I'm hoping that as we gradually get better and better at ethics, people are going to see this. I think that actually, whether it's the US or China that wins doesn't matter as long as you get safety and alignment.
Okay, interesting.
The real risk is not so much that you get the communist world or a Western world, but that you get no world.
Okay, interesting. So that's the biggest thing we have to worry about. Hopefully, we won't get there. Anders, it was an absolute pleasure. It was really nice to talk to you. I'd like to talk to you again sometime, because there's actually a lot of things I didn't get to at all. But
maybe let's do that next time.
Yeah, perfect. Thank you so much. I really appreciate it.